Hello guys, in this video tutorial let's talk about some vector mathematics concepts. In previous tutorial when we are talking about player and platform interaction, we used some of those concepts. I explained it over there and I said that I will take one separate video tutorial for this. So in this tutorial we will see some of the basic concepts of vector mathematics. The one that you guys are going to learn here, these things can be used in many places. So we can use this concept in our game, or whichever game you guys are going to develop, it is possible to use these concepts. And these are all very minor things, but it will help you at a large scale. So let's look into that. So I already created 3, 4, 5 scenes. So let's go with the scene name called vector. So this is the one, and one second. So what we will do is reduce this game object scale to 0.1 and this game object scale also to 0.1. So 0.1, 0.1, 0.1. Here also we will do the same. Okay, fine. Now let's see what is a vector. So vector is basically contains direction and magnitude. It doesn't contain position. This is what in mathematics term people will say, but this will be kind of confusing. So what I did here is I created a game object called A that is at 0, 0, 0, and I created one more game object that is at B 10, 0, 0. So now what we do is from A to B we draw one straight line, that is this is A, we draw a line from this point to this point. So whenever I adjust this B game object, either if I move left or right, you can see it changes. This is called vector, and vector has multiple dimensions. Currently we will be seeing only 2D vector because we are developing a 2D game, but in later but in actual mathematics we can use 3D vector, 4D vector, even n dimensional vector can be used. That's where this linear algebra comes in. And if you guys are interested in linear algebra, you can check out Gilbert Strang MIT Open Courseware video, but we won't be using all of those concepts over here. So here we are just dealing with x and y coordinates. So in x I keep it at 0 and y also 0, and this game object I keep it at x 10.06 and y 1.43. So if you see this, if I alter any of this game object, you can see this line is getting drawn from here to here. So vector don't have position, meaning I can move this vector, that is this two game object, even if I move up, down, left, right, you see this line, this red line remains the same. So this is the direction. So vector has two properties. You can remember something like this. Vector has tail and head. So in this case, this A game object, this is a tail, and this B game object, it is a head. So it means you can, let me show you in a paint program. It means you can draw a line like this, and if you put the arrow, this is called head and this is called tail. So in our case, this T is represented as A game object and head is represented as B game object. So we have head and tail, and this is the direction that our vector is pointing. So now if I move it like this, the direction changes. So I can do like this, so you can see you can move this game object 360 degree, it forms a circle, and each time whenever I change any of this position, uh, its direction changes. So basically I told vector has magnitude and direction. Apart from that it doesn't have anything. So in this case we can put something like this. What is the direction of our vector? We can do something like debug.log. We can say endpoint minus start point. So when you use this formula you get the direction, that is endpoint dot transform dot position minus start point dot transform dot position. This gives you the direction, and if you want to compute the magnitude, this is the formula. So you can use the same thing and you can put dot magnitude. It is a unity function. Now if you see, we have to put semicolon. Now if you see, the script will compile and the direction is 3.8, 0.6 and 0, 0. So this direction, if you draw it, it comes in like this, and this magnitude is 3.5. So what is vector magnitude? So from point A to point B, what is the length? So when we say I want the length of this vector, that is what this thing does. We say take the start point and end point minus this endpoint transformed position minus start point position. Once you get it, you will get one vector, that is this vector, that is 3.8, 0.6 comma 0. This is a line, so we are asking what is the length of this line. So when we say dot magnitude, we get the length of this line. So now let me move this here at 0, 0. So let's keep it 0, 0 here, and let's keep it 10 and 0. So now if you see, our vector is like this. Our vector is pointing in this direction. So we get 10 in x. It is a straight line in x-axis. This x-axis and this line is parallel. So we get in 10 in x 10, and in y there is no change, so it is 0, and in z also there is no change, it is 0. So this line, this is the direction of our vector, and the length of this line is 10. So I hope you guys understood about what is vector. Vector has magnitude and direction, but it doesn't have any position. So even if I move it like this, left, right, or up, down, the direction is like this. So you get the same direction 10, 0, 0, and the length is 10. So this is very useful in game development. So that is all about vector. And here in this case, this is our tail, and this B game object, this is our head. So you can put one arrow like this. So this is the head of the vector, and A object is the tail of the vector. So I hope this is easily understood. Next we will go for vector addition. So this, I created one scene where we can add two vector. So it is something like this. So this is a vector, this red line is one vector, and this is the head of the vector, and this point, this pivot point, is the tail of this vector. So there is one red vector and there is one blue vector. So this blue vector is over here and its head is here. Now what basically vector addition means is, we basically add this vector and this vector. The resultant vector is the green vector. So you can imagine something like this. So let's keep something like the color is red. You have a vector like this, and let's draw one more vector. You have another vector like this. Now when we add both the vector, the resultant vector will go from tail of the first vector to the head of the second vector. So this is what vector addition is. When we add these two vectors, this is the resultant vector, and this resultant vector head points to the head of the second vector, that is vector b, and its tail points to the vector a tail. So here it points. So this is called vector addition. So in this, again, vector doesn't have position, so I can move this vector anywhere, like this, but still you see this resultant vector is the same. Now if I increase the length of this vector, that is this vector a, if I adjust, see what happens. This resultant vector is also getting stretched, and there is this vector b. So vector a I represented with red line, and vector b, that is this blue, that is 0 comma 10 comma 0. Now if I increase like this in y-axis, see the resultant vector is also getting affected. Even I can do it in x-axis. So vector addition is basically you put the vector that you want to add at the head of the first vector, and when you add it you will get the resultant vector, where in this case this vector, this green vector, its head is touching the blue vector and its tail is touching the red vector tail. Okay, so this is what is vector addition. And next is vector subtraction. So this is also same. So what we do is we have vector a, that is red line. Okay, and so this vector tail is here and head is here, and we have another vector, its tail is here and its head is here. So when we subtract the two vector, that is when I subtract vector b from vector a, so from vector b if I subtract a vector a, the resultant vector goes like this, and now the tail of the resultant vector points to the head of the first vector, and the head of the resultant vector points to the uh, head of the uh, second vector, that is in this case this resultant vector tails points to red vector head, and the resultant vector head touches the blue vector head. So this is what this vector subtraction is all about. And now if I adjust the red vector, that is vector a, in x-axis like this, you see the resultant vector also changes like this. Likewise, if I adjust vector b, you can see it goes from here to here, and if I adjust the y position, you see still it goes from here to here. So this is what is called vector subtraction. Okay, so that's it. And for vector addition and subtraction, Unity gives some predefined formula. So if you want to add a vector, all you have to do is vector 3, you can say 1, you can say like new vector 3 of 0 comma 0 comma 0, and second vector is this 2 10 comma 0 comma 0. Now if you want to add a 2 vector, you can do 1 plus 2. This will give you the resultant vector, and you can store it in 2. Similarly, if you want to subtract one vector from another vector, you can use the basic arithmetic symbol minus, and you can store the resultant vector over here. And next we will go with vector scalar multiplication. Here I have kept a vector. Okay, this is a vector, and its uh, its start point is 0 and end point is here, that is this game object. So whenever I rotate a vector, whenever I move this game object, its direction changes and its magnitude also changes. Now if I want to scale this vector little bit higher in this direction, I have to say currently the scale amount is 1. Now if I say increase the scale amount to 2, you see the vector is getting scaled in that direction. Like that I can do 4, 5. If I reduce the scale, you can see the vector is reducing its scale, and if it goes negative, it points in the opposite direction. So see, it points in the opposite direction. So what basically vector scalar multiplication does is, whenever you want to scale a vector, you can use this. By scaling a vector, we are basically scaling the magnitude of a vector, but in this case the direction doesn't change. Even though I scale my vector like this, its direction remains the same but its magnitude changes. So whenever you want to scale one vector with another, all you guys have to do is uh, where did I kept, okay, so we have a vector 1. Okay, if you multiply a vector 1 that is 0 with anything, it will be 0, so make it 1 here. And when I do 1 multiplied by scalar value, the resultant vector will be scaled. But you can't do something like this 1 plus 2. You can add only vector and vector, you can't add a vector and scalar. So this is the rule that you guys have to remember it. If you want to scale a vector, multiply the vector by the scalar amount. So this is scalar vector multiplication, so that this allows you to scale the vector either in positive or in negative direction, but in this case direction won't change. The next one that we are going to see is vector normalization. So here also we have a vector. So this is a vector where its start point is here and the end point is here at 10, 0, 0. Now initially I said vector doesn't have position, it has direction and magnitude. Now in this case, if you see, this red vector length is 10, and when we say normalized vector, basically it will give you the direction. This is the thing that I was explaining you in player platform script. Sometimes you just need a direction of a vector in a normalized space. So when I say normalized vector, this whole red vector is normalized and it becomes like this. So if I move this vector like this, that is this red vector, you see the normalized version of this vector, that is this green vector. Now if I do like this in the similar fashion, every time this vector direction changes and it forms a unit circle. So unit circle, if you take a radius of any vector in unit circle, assume you have circle with you will be drawing unit circle like this where the radius is 1, and if you take any vector on the unit circle and if you compute its magnitude, its length will be always 1. So now if you see here, this red vector length is 7.4219. So from here to here the length is 7.4219, and even if I scale it, it will go bigger, 10. And even if I keep it like this in any direction, you see the length of the red vector is 5.6. But whereas when I normalize this red vector, its length is always 1, meaning it is nearer to 1. 0.99, if you do it, it will come to 1. So always the normalized vector magnitude is 1. So this will be useful where sometimes you just need a direction where you don't need this actual vector. So if somebody says, hey, which direction you are pointing, so in this case I am just pointing towards right, and when I say -10, I am pointing towards left. So all I need is this direction. I don't want to tell anyone that I am pointing in the left direction up to -10 or +10. So that is not needed. So if you see the normalized vector in debug mode, so if I put it, let me see. If you see the normalized vector, okay, let me write one public variable, say vector. This is a actual vector, that is our red vector, and public vector 3 green vector. I used vector 3, but only x and y value will be taken into consideration since we are in 2D game. So the z-axis will be left out to 0. Okay, so you guys don't have to think of z-axis. So now let me put red vector, that is equal to vector dot transform dot position, and green vector, that is the normalized vector, is equal to this vector dot transform dot position dot normalize. This is a unity function that does the normalization for us. So now if you see, the red vector is -10, 0, 0, whereas this normalized vector, that is green vector, is -1, 0, 0. So if I change this vector like this, anyhow, this normalized vector will be always in the range of -1 to +1 in x-axis and y-axis. So red vector is 1.65, 2.118, and when we normalize it, this green vector, its x value is 0.60 and its y value is 0.79. So this x and y will be always within -1 to +1 if you normalize a vector. And if you compute the magnitude of a vector, this green vector, this will be always equal to 1. So let me change it here. Whichever way I change, you see this normalized vector, that is this green vector, -0.5 and 0.8. So this x-axis is within -1 to +1 range, and this y-axis is also within the range of -1 to +1, and its length is 1. So that's all. These are all the basic concepts that one should know when working with the game development, and there are advanced concepts that are there, but that is not needed for this 2D game. I hope you understood all of this, and if you guys have any questions, please let me know. Actually, I should have taught these concepts first. before starting the player platform interaction. But anyway, from now on, before going forward, I thought better explain these concepts, so in future when I am going to use these concepts, people won't get confused. So that's all guys. We'll catch up you guys in the next video tutorial. Bye.